Hey everyone, this is problem number 4. Just go ahead and get started to give you a sense of just all that's going on. A market analyst wants to know if the new website he designed is showing increased paid views per visit. And a customer is randomly sent to one or two different websites offering the same products, but with different design. And accompanying table shows the data from these 5 customers, randomly selected customers, and completes part of A through C. So this is going to be part A, just to break it down and kind of talking at length about it. So here's the data that we have: website 1, website 2, and the number of page views. And so the first question is test the null at alpha using the pooled t-test. And what is our null? As you can see up here, there is no difference between website 1 and website 2. That's the null. So assume that the new website is 1 and the old website is 2. Pooled t-test is a hypothesis test for the difference in the mean of two independent groups. We're really able to assume that the variance of the groups are equal. The hypothesized difference, as I said before, is 0. So just kind of setting it up here, mean 1, mean 2, minus mean 2 equals 0, and the alternative, mean 1 minus mean 2 is greater than 0. So to give you a sense that if there is a difference. So the first step is calculating this test statistic, and I kind of put it here. It's pretty much, first find the sample sizes N1, N2, kind of based off of this. This is your t-test formula right here. That, as you can tell, we can't just go directly through here, and especially in Excel. So there's a series of steps that we have to do. It's very sequenced in terms of solving it both kind of logically and in Excel. So coming back to here, first we need our test statistic. So both of our n's are 5. What does that mean? Well, what that means, n, remember, is the sample population. So it's just essentially how many are in each column. So website 1, 1, 2, 3, 4, 5. 2 is this 5 as well. So that's really what that is. And then calculate the mean. What does that mean? 10.8, 6.4. It's exactly that. The mean of 1 and mean of 2. And I can show it up here just for your just for practice. Average, you can see website 2, the average should be about 6.4, and sure enough, it's 6.4. Give you a sense of that piece of the equation. And then S1, S2, these are the variances. So, what does that mean? It means kind of going here, you do var. There's a lot of options that you could do. For the sample, we'll do the sample, number 2, var, 4.8. So website 2 is 4.8, and as you can tell, website 2 is 4.8. Variance of website 1 is 5.2, meaning if we apply that same logic to our test, then we get the same. So, and then calculate the difference between the two sample means. So that's basically up here. 4.4 because it's 10.8, part 1 minus 6.4. And that's how you get 4.4. So after we find this out, and some of this information is useful to us, we then plug into this equation the pooled variance rather, because each is a component of one another. So you can see up here the standard error pooled is up here, it's this piece, but before we do that we get to this piece. What helps us, informs us of this piece, is this piece. So there's a series of steps in solving this, so it's not really as quick as you would think. So basically N1, remember N, both of our N's are 5. So it's 5 minus 1 times the variance of 1. When I'm saying 1, I mean the first sample up here. Up here, all the way up here. This is 1, website 2. That's what we're getting at when we're thinking of variables with these kind of subscripts. So 5 minus 1 times the variance of 1 plus 2 minus, or 1, 5 minus 1 times this variance for website 2. See, this is website 1, this section right here. This is website 2, divided by the sample population of website 1 minus 1 plus the sample population of website 2 minus 1. So basically 5 minus 1 is 4, 5 minus 1 is 4, so 8 is this denominator, as you can see here. And so in Excel, what this looks like is essentially that. In Excel, it is 5 minus 1 times 5.2, 5 minus 1 plus 5 minus 1 times 4.8, divided by the total of 5 minus 1 plus 5 minus 1. So what that gets you at is this 2.23 value, or 2.24 rather. So now that we have that piece solved, then this is our pooled variance. Now that we have the pooled variance, then we come down here and then we insert it into this equation. So you remember this is equal to the the pooled variance rather, times the square root of 1 over n1 plus 1 over n2. We already have a general idea of what that looks like, but in Excel it's essentially that. It's M24, this is our M24, our pooled variance, times the square root of 1 over 5 plus 1 over 5. So, and that gets us our 1.14. And then what we do is we come all the way down here to the t part, the t statistic, and we solve for it. Now we can finally solve for a t statistic. So what is this? The difference in the mean? It's up here because we had just done it. 4.4. So it's 4.4, and remember this is the null hypothesis for the difference, which is 0. So it is 4.4 minus 0 divided by this. And remember, we already calculated this up here. It's the same. So what we get is basically that 4.4 minus 0 divided by 1.414. And that gets us our test statistic. Now, we go all the way down here to calculating the p-value. We already have our degrees of freedom. Our degrees of freedom, 5 minus 1, parentheses, plus 5 minus 1, parentheses, so it's basically 8. But coming back to the p-value, as you can tell, we're using the t-distribution function. We want to know the t-value of the t with respect to the t-distribution. So what that means is R35 is our first, right here, our t, that goes in the first piece, as you can see up here. Then it's n, and it's right there. And then this is 1. What does this 1 mean? It's a very good question. What this means is that it is a one-tailed test. So Excel will appropriate the logic correctly. And so after you do all of those things, then you should get 0.0072. Then after that, if the p-value right here, so if the p-value is lower than alpha, we reject the null. So based off of this, the fact that is 0.007 greater than or equal to or less than 0.05. And sometimes if it's visually, sometimes like you'll have a high number, like this could be 8, and you think that this might be a larger number based on the value somewhere within it, even in decimal places. A good check is basically your p-value. So if, in terms of figuring out whether or not this can work, if, and you got to state your condition, if that is greater than 0.05, doing our alpha, remember, then reject, actually, we'll do it this way. Oops. So we're going to fix this a little bit. So if this one is less than alpha, so if our p-value is less than alpha, then we reject the null. Else we accept the alternative hypothesis. It's a little longer, but just to get the point across. As you can tell, now that we set up that rule, so we reject the null hypothesis in this case because the p-value is lower. And a good rule of thumb is if the p-value is low, it's got to go. You can kind of think of rhyming a little bit. But in any event, this is part one of this problem. We're going to go into more in depth for B and C to give you a better sense of just how much in deep this is, even though the question is not necessarily too long. But you just let us know if you have any questions along the way. All right, thanks so much. Bye.